All right, so our notes page today is a little bit different than what you're used to. Most of the notes are already on that reflections page that you have. Okay, so you're just going to be adding things to it or drawing pictures that are going to help you remember what's on that page and what you're learning. And I'll give you some guidance on that while I go through this lecture video. So the first thing I'm going to put up here, which you can already see, is I can graph reflections on the coordinate plane. That is our learning target today. Now you can write that down on your paper, you don't have to, but I want you to know your goal. By the end of this lecture video, you should know how to graph a reflection on the coordinate plane. All right, so here's your reflections note page. On the top, it has a coordinate plane here with some different locations, okay? And first, I'm going to talk about a reflection. When we think about reflections, we think about looking at ourselves in the mirror, like a reflection, right? The reflections we're talking about today on the coordinate plane are symmetry reflections. And what's symmetry? Well, when I learned about symmetry in elementary, the first time I ever heard the word and learned about it, I learned about butterflies. And I learned about how one side of the butterfly is exactly symmetrical to the other side of the butterfly. So their wings would look exactly the same, which made me, every time I drew a butterfly after that, draw the wings exactly the same because in real life they're symmetrical. So another name for symmetry reflection is also line symmetry, meaning across the line, things are the same. So across a butterfly, if you go right down the middle of a butterfly, either way going up and down, well, no, I guess just up and down. If you go right down the middle there, then if those wings folded up, all of those spots would match at the same spot because it's exactly symmetrical. Okay, so that's kind of what we're going to be doing. Just like those butterfly wings fold up, we're going to pretend that our coordinate plane is a piece of paper that we're going to fold. Okay, and remember it's line symmetry, so we're going to fold it along certain lines to copy a location. So our first ordered pair or location is this 2, 3. The 2 tells us, that first number tells us where the location is at on our y-axis, so our horizontal number line. So it's to the right 2 spots. And the second number tells us where our dot is at on the vertical y-axis number line, and it's a positive 3, so it is up 3. Here is our location that we're starting with. We are going to reflect this point 3 different ways. The first way we're going to reflect it is across the y-axis. So now think of this coordinate plane as a piece of paper, and if we were to reflect it across the x-axis, we're going to be folding along the x-axis line. Okay, so we'd be folding it like a hamburger. And then where that point lined up down now here in quadrant 4 is where that reflection across the x-axis would be located. So if we had those paper folded that hamburger style, and we could poke a pencil through both of those points because they'd be at the same spot. Our next reflection that we're going to look at is across the y-axis. So now we're going to reflect this point across the y-axis, the vertical number line. Okay, so now we're going to fold this coordinate plane like a hot dog. Okay, and if we fold it like a hot dog and then poke a pencil through where the 2, 3 is now, it would go right through this reflected point as well in quadrant 2. So that's the reflection of this point across the y-axis. And then we have one more type of reflection. And this reflection is across both the x and y axis. So to be able to reflect across both the X and Y axis, it'd be like you are taking the coordinate plane and folding it diagonally. Okay, so you'd be folding it diagonally from corner to corner, this top right corner down to the bottom left corner. Okay, and right where your point was at in this quadrant 1, if you poked that hole through with a pencil, that would make your reflecting dot down here in quadrant 3. And you can kind of notice some different patterns here with the signs. And the signs just mean, when it says signs, it just means negative or positive, whether it's a positive number or negative number. And when it's a positive number, we don't usually write the plus sign there. That's just, we just assume that it's there, that it's positive. We only write it if it's negative. So you'll notice that when we go across the x-axis, okay, our x value stays the same because that location is not changing. But our y value, the signs are changing, right? Because up here, we're up 3, and down here, we're down 3. And when you look at the reflection across the y-axis here, our y number, our second number, stays the same because that doesn't change. We're up 3 on both of those. That's not going to change. But when you fold and make that reflection, this one is going to be on the x-axis over a positive 2, and this one's going to be on the x-axis over a negative 2. So those signs will be different. And then with our last one, when we fold it diagonally and we reflect across the x and y axis, both of those signs change. So the 2 and the 3 are both negative now. Okay, because it's changing its location on the x-axis and its location on the y-axis. So it's the opposites, right? The opposite of 2 is negative 2. The opposite of 3 is negative 3. Okay, and it helps to draw this picture because a lot of times when you're looking at it and it says, oh, reflection across the x-axis, that means the x value is going to change. And that's not, right? If it's across the x value is staying the same. It's the y value that the sign's changing. So make sure you draw some type of picture to help you visualize that so you don't get confused. Okay, and before we go into